Alright, so in this example problem, we first have a spring that is horizontal. So we have a spring attached to a fixed position and it's being stretched out. So you're applying a force this way of 100 newtons and the spring is trying to act like a restoring force and pull the mass back towards equilibrium. So equilibrium would be x equals 0 and the mass is currently at x equals 3 centimeters. You're now going to take that same spring and hang it vertically. So we get the same mass attached to the same spring. Now it's being stretched underneath the weight of the mass. So the spring force is trying to pull up, the weight is pulling down, and so there's a point where x would equal 0 where the spring would end when the mass wasn't attached, and now you're down at x equals 10 centimeters. Now in order to complete this, we have to do two steps as you see over here on the left. I'm going to sum first my forces when the spring is hung horizontally, so there's a force applied of 100 newtons, and then the spring is acting as a restoring force, and we know the spring force is equal to k times x. So I'm going to plug in my 100 newtons and how much the spring is stretched when the 100 newtons is applied in order to first find the spring constant. And then I'm going to use my vertical, where the restoring force is the spring and it's being pulled down by the weight of this mass here. We now know the spring constant. And we can multiply that by the amount the spring is now stretched out, which is the 10 centimeters. So 0.1 meters. And we're looking for the mass. And we already know what the acceleration due to gravity is on Earth's surface. So we can find out the mass is 34 kilograms.